Our world is forever changing for both human-induced and natural reasons. The ever-growing catalog of remotely sensed data gives us a unique insight into these changes. Our data have become multi-temporal, spanning across years, seasons, months, and weeks. In some cases, we even have reason to view changes in particular places over a matter of days. In ENVI, we have introduced a number of spatiotemporal analysis tools that allow users of remotely sensed data to quickly perform analysis throughout time and space. At the foundation of the spatiotemporal analysis toolset is the ability to build a series of rasters and then view the series incrementally throughout time. Users can also quickly regrid the series to a common projection and spatial extent, ensuring that each pixel in any given raster lines up exactly with other corresponding pixels in the time series. These spatiotemporal analysis tools are all available in the ENVI toolbox and can also be called programmatically via the ENVI task system. The ENVI task system enables users to string together discrete image pre-processing and analysis tasks into a workflow. ENVI tasks can be deployed in the ENVI desktop and on an enterprise or cloud-based system via the ENVI services engine. Let's take a look at how we can use these tools to perform multi-temporal analysis. We will start in Clark County, Nevada, where the city of Las Vegas has undergone steady growth for the past several decades. Using Landsat data available from the USGS EROS data center, we can observe how the city has steadily grown outward as new subdivisions have been added to the grid. Using a combination of spectral indices, we can view this change in a different way. With a combination of a built-up land index, a vegetation index, and a water index, we can see how these various features have changed throughout time. Spectral indices provide a unique way of increasing variation between spectral bands prior to running image classification and change detection. The ENVI services engine provides the ability to perform image analysis in a cloud environment, regardless of where your data is sitting. You can even perform analysis on image services. Here we have loaded our Las Vegas data into a catalog and are accessing it through a web page using the Esri JavaScript API. We can view any of our images and perform various analysis tasks, including change detection, on any two scenes available in the catalog. Once we click Go, our request is sent to the ENVI services engine and it executes a series of ENVI tasks. When the tasks are complete, the results of our change detection are returned to the web page. In our next example, we will turn to the Great Lakes region of North America. We have a unique data set from the Moderate Resolution Imaging Spectroradiometer aboard NASA's Terra satellite. This dataset contains 16-day NDVI values throughout an entire year. In ENVI, we can use our series manager to play through the rasters contained in the series. We can adjust the interval time between series, we can stop the series and click backwards or forwards through time. We can load the currently displayed raster to the ENVI display, or we can export the series to a movie in many different formats. One of the more powerful features of our spatiotemporal analysis toolset is the ability to display a series profile. This tool allows us to determine the value of any given pixel throughout time. Because we are displaying an NDVI series, we can quickly determine what the value for NDVI was at any given time throughout an entire year. We can display the value for just a single pixel in our series profile, or add multiple pixel values to the profile display. We can choose an appropriate name for any of the pixels being displayed, and add a legend to the display. When we are finished, we can export our series profile to many common image formats, or even send it directly to a PowerPoint presentation. For our final example, we will turn to the Central Valley of California. California is currently undergoing one of the worst droughts in its history. This has put an intense focus on precision agricultural practices. We have acquired high-resolution Pléiade 1A and 1B imagery from Airbus Defence and Space. The high resolution of these sensors, coupled with the ability to rapidly revisit the same areas on the Earth's surface, make it ideal for looking at crops down to the level of individual fields. Using the spatiotemporal analysis tools we have previously discussed, we can build a time series to view how crops are behaving throughout a season. High-resolution imagery from commercial satellite, airborne, and UAV sensors can provide farmers with information about when to harvest a crop, where to move watering equipment, where to apply insecticides and pesticides, and can even be used to determine crop estimates. Here we are looking at an individual field throughout the growing season. Using our series profile tool to view an optimized soil-adjusted vegetation index, we see that crop health steadily increased until sometime in the middle of June. By June 23rd, crop health began to decline, and we even see signs of crop loss in the northwest corner of the field. This is just one example of how remotely sensed data can provide insight into conditions that might not be readily available from the ground. For more information on how the ENVI product stack can be used to analyze your data, please contact us. Thank you.